If you are visiting our channel for the first time, please subscribe first to get the basic and advanced maths concepts. Today we will learn how you can find the equation of ellipse when you are given with foci and vertices. These are the two elements of the ellipse, that if you are given with the coordinates of the foci and the coordinates of the vertices. So step 1 is we have to find the major axis. As in the previous lecture we have seen that we have to always start with the with finding the major axis first, then we move forward. So in order to find the major axis, another method is plot the elements of the ellipse that are given in the example. So let's plot the foci and vertices on the coordinate axis. As we have the two foci with the two values, one is 4 1. So first of all we will on the coordinate axis as 4 1, it means its x coordinate will be 4 and y coordinate will be 1. This is one focus. We will label it as f with the coordinates 4 and 1. Then we have the other focus as 0 1. 0 1. 0 is on x-axis and y is on y-axis. So 0 and 1 will be this point. So we will label it with f dash, that is another focus, 0 and 1. Now another element of the ellipse are the vertices. We have two vertices. One is on -1 and 1 and the other is on 5 and 1. First of all we will plot -1 and 1. So this is one vertex and we will label it with V for your convenience. So V dash is -1 and 1 and V is 5 1. So let's plot it as well. So this is another vertex, 5 and 1. So we plot the elements of the ellipse that are given in the example, and from this plotting we can easily determine the major axis. How? Let's see. For the major axis, always in the focus and the vertices always lie on the major axis. So here we have seen that the focus and vertices are lying on an axis that is parallel to the x-axis. It means its major axis is x-axis, but it is parallel to the x-axis. So the focus and the vertices lie on the x-axis. So that's why we can say easily, as foci and vertices lie on axis that is parallel to x-axis, so major axis will be x-axis. So this is the step number 1. We have determined the major axis. Then we move towards the step number 2. 2 is we have to decide which equation of ellipse is to be used. Now the equation of ellipse will depend on the one thing is it depends on the major axis, and it also depends that what is the center of the ellipse. So we have to consider the two things here. One is center of ellipse in order to decide the equation of ellipse, which equation of ellipse is to be used, and the other is the major axis. Now based on these two things we have to find the equation of ellipse. So as it is clear from here that the center of the ellipse is not 0 0, so we cannot use the standard equation of the ellipse. Here the center is what? Let's see. As the center lies in between the two foci, so it means its center will be at this place. This is the center with the coordinates 2 and 1. So it means this ellipse is the shifted ellipse, not the standard one where the center is 0 0. So the center is 2 1 with the coordinates 2 and 1, and the major axis is x-axis. Then what will be the equation of ellipse? Let's see. For shifted ellipse we have the standard equation as, if I write here, x minus h whole square divided by a square plus y minus k whole square divided by b square equals to 1. This is the one equation, and the another one is x minus h whole square divided by b square plus y minus k whole square divided by a square equals to 1. These are the two standard equation of ellipse that can be used in case you have the shifted ellipse. Now which equation we have to use in this case is depends on the major axis. As the major axis is x-axis, so we have to use which equation? So as major axis is x-axis, so we have to use this equation, this standard equation of ellipse, so and ignore this one as the major axis is x-axis. Then what we have to find out in order to use this equation as and what is known, let's see. It will be done in the step number 3. In step number 3 we have to find a and b. As h and k as for h and k we have already find what is h and k. H and k is basically the center of the ellipse. As this is the shifted ellipse, so center will not be 0 0, and we have to find its center that we have found already, and that is h is equals to 2 and k is equals to 1. So from where we have found h and k basically the center. This is c, h and k. So h is 2 and k is 1. So we have h and k, and what is left is a and b. So we have to find a and b in order to put the values in equation number 1, that is the standard equation of ellipse, to find the equation of the ellipse with the given foci and vertices. So for finding a and b, let's see what we have to do. A is basically the number of unit of the vertex that is away from the center. As the vertex is at this point and another vertex is at this point, so we have to check how many units it is away from the center. Center is at this point, it is at 1 2 3, so the vertex is at a distance of 3 units from the center, and we can easily say that the value of a is 3. A is equals to 3. Now what is b? Is basically the number of units of the co-vertices, and we don't have co-vertices here, so we have to first find the c, and once we get the c, we can easily find the b. C is basically the number of units of focus from the center. So let's see how many units it is away from the center. This is center and this is focus. So center is at 2 and focus is at 4, so it means it is at a distance of 2 units. So we have the value of c as 2. C is equals to 2. So once we have got a and c, we can easily find the value of b by using the formula of focal length, that is c square is equals to a square minus b square. Let's rearrange it in order to isolate the b on one side. So b square is equals to a square minus c square. B square is equals to, what is a? It's 3 square minus 2 square, and b will be equals to under root 5, that is 2.23. So we have got the value of b as well. Now we have got a and b and h and k, so we just need to put these values in the equation 1, that is the standard equation of shifted ellipse. So let's put it in that equation and get the required equation of ellipse. The equation is, now what is h? H is 2, x minus 2 whole square, and what is a? A is 3, it's 3 square, plus what is k? Y minus 1, k is 1, divided by what is b? B is under root 5. So if I write under root 5 here, I have to write it like this, under root 5 square, or you can also write 2.23 equals to 1. So this is the required equation of ellipse, and let's plot it now. Let's plot the ellipse, that how it will look alike, as we have also find the value of b, that is the value of co-vertices. So it means it will lie at a distance 2.23 units away from the center. So we have to add 2.23 in the center in order to draw the ellipse. So 2.23 in the x value, as co-vertex will lie on the y-axis. So we have to add 2.23, it means this value, into the y-vertex of the center to draw the co-vertex. So y coordinate is 1, so 1 plus 2.23 is 3.23. So let's plot it on the graph as 3.23 here. So it means co-vertex will be at this point from the center, and similarly we have to move the same units in the downward position, as by subtracting 2.23 from the y coordinate, as 1 minus 2.23 will be, so it will be at minus 1.23. So this is another vertex. If I label it, this is b and this is b dash. Now let's draw the ellipse by joining these points, as it will look somewhat like this, as it is as we have drawn it roughly, but its shape will be like this. So that's all from today's lecture, that how you can find the equation of ellipse if you are given with foci and vertices, and how you can plot it on the coordinate. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.